Hi, welcome back to my Allen Bradley PLC test bench. Today we're going to be going through the Allen Bradley 771 ASB. This is the original remote I/O module for communicating to remote chassis in the 1771 series. Nowadays people are ripping these out and ripping out the chassis and putting in Flex I/O with ASBs, or putting in control logics racks with ENBTs or EN2Ts or EN3TRs or something like that for Ethernet communication. But there are literally millions of these installed out there in the field. So they're not going away anytime soon, and you need to know how to operate them. They're pretty simple. There are a set of dip switches here, and to change dip switches, don't ever use a pencil. What I've got here is an oil seal pick. It has a very sharp end on it. There's various items you can get like this, and you just flip your switches back and forth. Very simple. Pencils have been known to break off, and graphite can actually take and play with the resistive properties of these switches and make it so they don't work right and give you errors. The switches are explained in the installing your module on the publication. I suggest you find the publication and download it. I'll see if I can put a link on the page or put a PDF there. And the other thing with the remote I/O is there's also the 1794 ASB, and they're both basically do exactly the same thing. It's just a different format. It's a 1771 chassis, which, as we all know, was made to last 80 years, or the Flex I/O chassis, which were made to last 7 to 10 years. And some of them are lasting longer, some of them are lasting less. So keeping the old chassis up and running is a good thing. They're going to last you forever. So anyhow, we'll swing around here and we'll go through the steps. It's quite simple, but be right back. Okay, we're back. So here's our setup for testing. We have a 540E Series E with a data highway and remote I/O. Our remote I/O link to our ASB is on channel 1B. And if we follow the blue hose down, which is that blue cable, we come to our chassis. And here it is terminated. Now, if you have, depending on which speed you set it at, you have to have a resistor across there. And it's 82 and 110, I believe, depending on what it is. And you only have one at either end. It's no different than having a fire alarm system for your resistors. One at either end, and that's it. If you have multiple resistors, you start introducing communication errors. So anyhow, let's have a look at the back of our chassis. And this is usually something you only set up once. Now, since we're in a PLC 5, not a 2, not a 3, not a 250, here's how our switches are set. Move that right over there. And there we go. So last state, when on, they stay where they are. When it's off, the outputs are de-energized. Safe state is always to have it so that the I/O outputs go off, so that you can control what's happening. Processor restart on a power down, power up. The processor can restart this chassis. You don't have to come out here and push a button or do anything strange on it. Then two are always off, and then there's your addressing switches. You can select, as you can see with switch number 5 and 6, half slot, 1 slot, or 2 slot addressing. And originally everything was 2 slot, And then they went, Allen Bradley developed one slot, and then they developed half slot. Half slot you use with 32-point modules. So, looking at our chassis here, our last state switch is off, so that the chassis, when it goes off, the outputs go off. And that is pushed in on this side here. The second is on this side, it's on. The processor can restart the chassis. And then the rest of these are all off, and that gives us 2-slot addressing, and everything else doesn't matter. So our next step, we'll just flip that. The only time you should ever have to play with that is when you set it up originally from a fresh system. So here's our ASB, and of course they always sit a little cockeyed. This is our speed switches. As you can see right here, it tells you how to set them. And the thing it doesn't tell you on there, but you do see here that pressed in at the top is on, pressed in at the bottom is off. So in this case, we want to have, we're set for 230 kilobaud, and our chassis is set for rack number 10. And our beginning group for this is 0. Now you can have 4 of these chassis, single A1Bs, if you wanted, and each one would start at a different address. But that's an entirely different setup. So this one's ready to go. And like I say, rack 10, 230 kilobaud, and 2-slot addressing. So we'll just swing back out here a little bit. Power always off when you're putting these old guys in and out. And you want to, if you put your thumbs there and press in at the same time, you're going to get a nice solid clunk. Bring that up. These sometimes don't snap down, you have to push them down. And we power up, and you can see we have our active light, and this card is flashing because I have this switch up. And if I change the lighting a little bit, you can see that easier. And this one, it just turned on that light. So there we go on that. Now, the reason I've got this set to rack 10 is I've got a stack of ASBs to test. So I test each ASB one at a time, power off, make sure the switches are all set the same, plug them in, do my 230, and on rack 10, 115, 57.6, and then I change to rack number 7. Now the reason I changed to rack number 7, and again we'll just zoom back in here so you can see, is that you look at the rack number 7 and rack number 10 dip switches. We have on, off, and then we go on, off, off. Those 4 switches are the main ones that are always used for 99% of your rack addressing. So if you do the one set and then do the other set, you know that you've tested all of those switches that need to be working. If any one of them is not working properly, then you'll get a different address and you'll get errors. So you'll know that you've got a bad switch. So there we go. That's the easiest way on that part. And next we'll go to the computer screen and have a look at how everything is set up in there to communicate with the ASB. So just give me a minute to swap around. Be right back. Okay, so here we are back at the computer screen. So if we go into our channel configuration, which zoom in and go right up there, channel configuration. a little plus there. RIO configuration is a different setup. Now if we look at our configuration and we swing back over here, now we're using channel 1B as our communication to the remote RIO. And as you can see, we're set at rack 10, beginning group 0, and it's a quarter chassis. No faults. And you have to set the diagnostic file, or you can let it do, and when you're in program mode, notice right down here, auto configure. So if we want to change the speed on our chassis, and all of your ASBs in your system must be the same speed. There's no one at 230, one at 115, one at 57.6. They all must be the same. That's the way these older systems are set up. So I'm just going to go over here, power it down, unplug it, and I'll bring it around here to the front so you can see. So currently, this is in the right spot. Hopefully, there we go. So we're set at 230, as you can see, 0 and 1. If we want to change to 57.1, we flip that one, and now we're at 57.1 for our speed. We put the module back into the chassis. Power it up. Now, we'll just look here real quick, but you can see here it is powered up. You can see a little green light there, but there's no LEDs happening on here. So that tells us, if you walk into this situation, that tells you there's something going on. So in this case, we know that the speed has been changed on this particular module. So we go back here to the screen, and there's our baud rate, our speed. We change the switches to 57.6. We know that's what it is. But just changing it there doesn't do us any good. We have to apply. And the software recognizes that you're in run mode already. We look at the top corner, and it says it has to be in remote program mode. And this is going to shut down your entire system. You have to be aware of that. So we hit yes. It changes it, and now we're back. And if we go look at our module here, you see how the light is flashing. It says, I'm communicating, but you're not in run mode. Go back here again. Change back to run mode. Yes. We look at our module, and now we got our solid green. Our lights are flashing on off here, controlling through the program. Go back over to here, and we say OK. Now you notice down here at the bottom we've got an auto config button. To make the auto config button work, you have to go into program mode here first. Change to program mode, yes. You're shutting down your entire system. Now we go back into the channel configuration, and we look into our channel 1B. And if we just take and delete what's there and say apply and OK, now we're only running, if we go up and look at the processor, you can see that there's only the data highway light on. The second channel, which is really hard to see at this angle, but is off. So we come back down here, and if we look at the chassis, You can see no lights are on. The outputs are off, so we're in safe mode. Let's go back here to our channel configuration. We go back to channel 1B. Okay, so we know we're at 57.6 because we confirmed that earlier. And channel 1B is our remote IO scanner. We hit, and our diagnostic file, which has to be there. It holds all of the information for the chassis that are out there. We hit auto configuration. It goes through and it says it found me. It found the ASB. We go back over here and look at the ASB, and yes, we're back and alive. Come back here again. Say OK. Now you have to say OK again, and it saves that information. Go back to your your remote program button here. Go back to run. Yes. And over here, and you can see everything's back and happy. So that's a procedure that you have to follow to get these things to work. You can't just flip switches and plug things in and out live. You have to turn things on and off. Your system has to start up and shut down. And that's the way these things are. But because they're built the way they are, they're going to last you the 60 or 80 years that they were designed for. Thanks a lot. Come back again and subscribe if you'd like. Have a great day.